Hello everyone. Today we'll talk about ratios. As we said the last time, the ratio is comparing two quantities. For example, in this figure, we can see that there are 2 girls and 4 boys. So the ratio of girls to boys is 2 to 4. It can be written as a fraction too. So the number of the girls over the number of the boys, which is 2 over 4. Now we can say that the ratio 2 to 4 is linked to the fraction 2 over 4. As we have equivalent fractions, we can have equivalent ratios too, like 1 to 3, 2 to 6, or 3 to 9. Why they are equivalent? They are equivalent because all of them are linked to the fraction 1 over 3. So we know that if we enlarge the fraction 1 over 3 by 2, we'll get 2 over 6. If we enlarge this fraction by 3, we'll get 3 over 9. So all of them show me the same value, which is 1 over 3. Another example can be the ratio 1 to 5, 2 to 10, and 3 to 15. Okay, they are all related to the fraction 1 over 5. So if I enlarge 1 to 5 with 2, it will be 2 to 10. If I enlarge by 3, it will be 3 to 15. Let's have a look at some examples from the exercises that are found on your book. Exercise 1, copy and complete the number of beds to the number of balls. So the number of beds is 1 and the number of balls is 3. So as a fraction, this one will be 1 over 3. And which fraction is the ratio linked to? As we said, it is linked to the fraction 1 over 3. Okay, let's see the second one. We have to find the ratio for the number of beds to the number of balls. So we have how many beds? 2. And how many balls? 6. Okay, so the number of beds is 2 and the number of balls is 6. So this one is linked, this ratio is linked to the fraction 2 over 6. Okay, at the third one, again, this kind of example, we have to find the ratio for the number of beds to the number of balls. The number of beds in this one is 3 and the number of balls is 9. So as a fraction, it will be 3 over 9. Okay, this is linked to 3 over 9. Now, if we compare the questions 1, 2, and 3, the exercises, do we agree that the number of balls is 3 times the number of beds? Let's check it. The number of beds is 1. The number of balls is 3. So the number of balls is 3 times 1. At the second one, the number of beds is 2. The number of balls is 6. So it is 6 is equal to 3 times 2. Okay, so it is multiple of. Okay, so this relation is right. At the last one, 9 is equal to 3 times 3. Okay, so we agree that this one is right. Do you agree that the ratios 1 to 3, 2 to 6, and 3 to 9 all show the same thing? Of course, we know that all these fractions are equivalent fractions. Okay, so they are linked to which fraction? To the fraction 1 over 3, all of them. Okay, so these ones will be the answers of the exercises. Now let's find the equivalent fractions or the equivalent ratios to the given ones. At the first one, it is given the ratio 1 to 2, 3 to 6, and the equivalent to this one will be, so as we see here, we have increased or enlarged by 3 the ratio, and here I have enlarged by 5, so it will be 5 to 5 times 2 is 10. Okay, so I have the ratio to something to 3, 4 to 12, 5 to 15. So if I have equivalent ratios, it means this 3 to become 12 is multiplied by 4, which means the first one must be 1. Let's check for the other ones. So 5 times 1 is 5, 5 times 3 is 15. Okay, this one is okay. 10 to what? 10 times 3 will be 30. So it will be 10 to 30, the other ratio. Okay, it's like taking the equivalent fractions, the same procedure. 1 to 5, so it becomes 3. 1 becomes 3, it means it is multiplied by 3. 5 will be multiplied by 3, will give me 50. So it will be 3 to 15. And 5 to 5, so this one is 5, and the other one will be 5 times 5, 25. Okay, so this one will be 25. Let's check D, 2 to 16. So if this one is 1, it means it is multiplied by 2 to come 2, which means 16 divided by 2 is 8. So this one is the ratio 1 to 8. So 3 times 8 will be 24. Okay, 3 to 24. And the last one, I have 2 to 5. I have 1, I have 4, and I have 7. Okay, so let's think about this one. I have 1 which becomes 2 and something which becomes 5. So for 1 to become 2, it means I have multiplied with 2. Okay, 1 goes to 2, which means I have multiplied with 2. Okay, 1 times 2. Now something is multiplied by 2 and becomes 5. Okay, I have to find what is this number here. So let's say this one is x, and now I have an equation. X times 2 is equal to 5. So x will be what? 5 divided by 2, or 5 over 2. Okay, I can express as a fraction 5 over 2. So 5 over 2 times 2 will give me 5, which means 1 to 5 over 2 will be the ratio. Now, if you multiply with 4, it will be what? 10. Okay, so 4 is divided by 2, it will give me 2. 2 times 5 is 10. If you multiply by 7, we'll have what? 35 over 2. Okay, 35. So 5 over 2 times 7. As we know, we can write 7 as 7 over 1 with denominator 1. And we know that when we have the multiplication of two fractions, we multiply numerator with numerator, which is 35, and denominator with denominator, which is 2 times 1, it is 2. Okay, so these ones will be the answers for exercise 5. Now let's pass to the other part. We have to write each ratio to the simplest form. Okay, this one is important because always the ratios will be given in the simplest form. So if I have 10 over 2, or the ratio 10 to 2, 10 to 2, I know that 10 can be divided by 2. Okay, it is divisible by 2. So the equivalent ratio to this one will be 5 to 1. Okay, 5 to 1. So this one is the simplest ratio, and the ratio that we have to use. B is 2 to 10. Same thing, 2 to 10. It means I have to simplify both numbers by 2. It will be 1 to 5, the equivalent one, the simplest one. We can take another example. Let's take 300 to 50. Okay, let's take the ratio 300 to 50. Okay, we know that 300 is divisible by 50. So 300 divided by 50 will give me 6 to 1. Okay, so 6 times 50 is 300, and 1 times 50 is 50. So the simplest form of this ratio will be this one. Let's take this one, 144 to 12. 144 to 12. Well, we know that 12 squared is 144, so this one can be simplified with 12. It will be 12 to 1. Okay, it is same as simplifying the fractions. Okay, 144 over 12. Okay, we can simplify this one by 12 and this one by 12. And the new fraction will be 144 divided by 12 is 12, and 12 divided by 12 is 1. Okay, so we use the same procedure that we use into simplifying fractions for the ratios. In the same way, you can continue the others at this exercise. Exercise 3, we have to draw 3 different rectangles with longer sides with this ratio. It means the longer side to shorter side is 3 to 2. So what does it mean? If the longer side is 3 centimeters, the shorter one will be 2. Okay, another one that we can have, it means we must find some equivalent ratios to this one. So let's find. As we said, if one of them is 3 centimeters, the other one will be 2. Or if I enlarge by 2 this ratio, if one of the side is 6 centimeters, the other one will be what? 4. Or if one of them is, if I enlarge this one by 3, 3 times 3, 9, the shorter side will be what? 2 times 3, 6. Okay, so we can have like this a lot of different rectangles. Let's draw them. The question is to draw. Okay, let's suppose one square is 1 square is 1 centimeter. So the first one will be 3 centimeter. Okay, to 2. The second one will be 6 to 4. Okay, 6 to 4. And the other one will be 9. 1, 2, 9 to 6. Okay, so this one will be the third rectangle. So as we see, they are all different, but the ratio of the sides is same. Okay, the ratio of the sides is same, 3 to 2. Okay, so this one will be the answer for exercise 3. Exercise 4, in what ratio are the sides of a square, an equilateral triangle, and a rhombus? So what do we know for a square? We know that all the sides in a square are congruent to each other. Okay, they have the same length. Same for equilateral triangle and same for the rhombus. It means all the sides of these figures are same. So if the sides are same, so let's start with the square. Okay, if all these sides are equal, it means if this one is A, this one is A. So the ratio of the sides will be A to A. Okay, and if we simplify this one by A, if we get another equivalent ratio with this one by simplifying with A, it will be 1 to 1. Okay, so the ratio is always 1 to 1 to 1 to 1 if we take the four sides. For equilateral triangle is the same thing. We know that all the sides of an equilateral triangle are congruent. Okay, so if this one is an equilateral triangle, all the sides again will have the length A, A, A. Okay, so the ratio of the sides will be A to A to A, which is in the simplest form 1 to 1 to 1. Okay, a rhombus, it is the same thing. Even the sides of the rhombus are equal, so the ratio will be 1 to 1 to 1 to 1. So let's write 1 to 1 to 1 to 1. Okay, so if the length of the side is 2, it will be 2 to 2 to 2 to 2. And if you simplify it to the simplest ratio, again, it will be 1 to 1 to 1 to 1. Okay, so this is exercise 4. Now, on the other part, we have exercise 1. What fraction of the squares is shaded? So it is given a 3 by 3 square. Okay, it means a large square is divided into 9 small squares. What fraction of the square is shaded? So if we write the fraction, we have in total we have 9. Okay, 9 small squares we have divided into 9, and the shaded ones are 1, 2, 3, 4, 5. Okay, so as a fraction it will be 5 over 9. What fraction is white? Well, white will be 4 over 9, the remaining part. What write a ratio to compare the shaded fraction to the white fraction. So if I want to write a ratio, it means it will be 5 over 9, okay, to 4 over 9. So I am comparing the shaded region to the white region. Write a ratio to compare the number of the shaded squares to the number of the white squares. Well, we said that the number of the shaded squares is 5, and the number of the white squares was 4. So the ratio will be this one, which means these two ratios must be equal to each other. So we can write that 5 over 9 to 4 over 9 is same as 5 to 4. Okay, so since these ones are the same denominator, it means they can easily be simplified or taken out, and it is same as taking 5 to 4. So if we have fractions as ratios, we have to equalize the denominators so we can take out them, and the ratio will remain with the same numbers. Let's practice on the other example. So exercise 2 will be your homework. You will solve same as we did in exercise 1. Now I will pass to exercise 3. We have to write each ratio in its simplest form. So at the first one, I have 2 to 5 to 3 to 5. As we said, if the denominators are same, this ratio can be written as 2 to 3. Okay, so 2 to 5 to 3 to 5, okay, is same as 2 to 3. Okay, so this ones simplifies each other. Okay, if we think as division, we know that we have to reverse the second one and they will be simplified. If we think as division, as we know, 2 to 5 okay, divided by 3 over 5 as we said, it is 2/5 times 5/3. Okay, we know how to divide fractions. So these two get simplified. It will be what? 2/3. And we can write the fraction as a ratio. We said it is 2 to 3. Okay, so this one will be the fraction. In the same way, we can say for the second one, 3/8 to 5/8 will be what? 3 to 5. Okay, 3 to 5. Same thing, 1 to 6 to 5/6 will be same as 1 to 5. Same thing, 7/12 to 5/12, it will be 7 to 5. 9/15 to 6/15, it is 9 to 6. And the last one, 5 to 6 to 1/2. Now, as we see, the denominators are not equal. So we cannot write this one as 5 to 1. First of all, we have to equalize the denominators. It means I have to make these two 6. So I have to multiply with 3 this fraction. And this one will be 5 to 6/6 to the fraction 3/6. And now I can write as a ratio 5 to 3. Okay, 5 to 3. So this one will be the ratio. Okay, so as we said, to write the ratio when two fractions have different denominators, we have to equalize the denominators. I will do the first one, and then you will continue with the other ones, okay? So 4/5 to 9/20. Okay, so 5 and 20 are different, so I have to enlarge this fraction with 4 to make the 5/20. It will be same as 16/20 to 9/20. Okay, so the ratio is what? 16 to 9. Okay, let's take another one. Let's take the last one. 3/7 and 4/5. So as we see, 7 and 5 are not equal, and we can equalize them by using least common multiple, okay? So the least common multiple of 7 and 5 will be 35, which means I have to enlarge this one with 5 and this one with 7. Okay, so we are changing both of the fractions. So this one will be 15/35 to 28/35, which is same as 15 to 28. Okay, in the same way, you can continue with exercise 4. It means the remaining one, B, C, D, E, as homework. So far you had as homework exercise 2 and exercise 4, B, C, D, E. Okay, that's all for today. You can upload the homework on Google Classroom. I wish you a nice day.